Welcome back to another math lesson with me, Mr. Duclos. Today, our objective is to use the area model to compare decimal numbers and to record using the greater than, less than, or equal symbol. Let's jump right in and see what we can do. The first two decimals that we're going to compare are 0.19, decimal 19, and 0.3, decimal 3. And we're going to use the area model to compare them. So I've drawn two area models out. Now there's a couple things we need to remember when drawing the area model. First is, these two objects are the exact same size. I'm not a perfect drawer, so I didn't make them exactly the same size because I can't. But in our heads, we need to know that these are equal areas. The same goes true for how much is in each section. If I break it up into tenths, it's 10 equal sections. If I break it up into hundredths, it's 100 equal sections. Again, I'm not a great drawer, I'm not a perfect drawer. So some are bigger than others. But we have to know in our head that in reality, every box is the same size. All right. So the first number that we're going to draw out with using our area model is decimal 19.19. For our area model, I drew it out as hundredths because we have a number in the hundredths column. Right? So if we broke out decimal 19, we would see that there's 1/10 and 9 hundredths. So I knew that I was going to have to break my area model into hundredths. So I'll fill out the 1/10 first. And then 9 more hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we have an area model representing 0.19. Our second area model is asking us for decimal 3. Decimal 3 I just broke up into tenths. The reason I did that is because there's nothing in the hundredths column. So I don't have to worry about that. I'm only going to break it up into tenths. And how many tenths do I have to color in? 3. So 1, 2, and 3. And then all I have to do is compare. I can see that on my 0.19, I have a full tenth, and then not quite another one. And over here, on my 0.3, I have 1, 2, 3 tenths. So quite clearly, I can see that decimal 3 is more than decimal 19. Decimal 19 is less than decimal 3. Decimal 3 is greater than decimal 19. Now that might seem pretty obvious to us to start, but the thing I want us to notice is when we're going on to the decimal, the most important numbers to show how big a number is closer to the decimal. It doesn't matter as much how far down we go. The number that's going to be greatest is the biggest number closest to the decimal. I could have made this 0.19, 2, 3, 4, 5, 6, 7. Decimal 3 would still be greater because we never got to even 2 tenths. It's a little hard to think of intellectually because we think of bigger numbers, the longer the number is, as having greater value. But that's not necessarily true when it comes to decimals. And the area model really helps bring that to life. Let's try one more. Now we're going to compare two decimals using a number line. The two decimals that we're going to compare are 7 decimal 2 and 7 decimal 02. Now, the whole number in front isn't super important. It could have been 0.2 and 0.2. It could have been 100.2 and 100.02. What we're really comparing here is the decimal 2 versus the decimal 02. And what I've done is I've drawn a number line starting at our lower whole number, 7, and going to our higher whole number, 8. And I did that because I can see that I'm not actually getting any bigger than 8. So I don't have to go past 8. So the first number is pretty simple. I'm just going to be able to count by tenths, which I already did. 1/10, 2/10, 3/10, 4/10, 5, 6, 7, 8, 9, and 10 tenths. So if I look at my number line, I can see that I have 7.2. 7.2. Well, 7.1, 7.2, 3, 4, 5, 6, 7, 8, and 9. I can see right away that my point is going to be right here. Right dead in the center, 7.2. So now I have to plot my 7.02. But 7.02 isn't going to fit on one of these lines very easily because it is 200ths. 200ths. So what I notice is I have 0/10, so I'm not even at 7.1 tenths. I'm at 200ths. So I'm going to break this up into 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then this down here would be 7.02. So again, the thing that's important to notice is just because this number has more digits, has more place values, it has a ones, a tenths, and a hundredths, it might look bigger, but it's not, because what determines our value is always on the larger end of the place value chart. So 7.2 is going to be larger than 7.02 because we're and the tenths versus in the hundredths. Now let's move on to one of your independent assignments before you finish on your own. Now we're going to do one assignment from your independent Google Forms. If you're using Seesaw, that's great. This is still really good practice, but afterwards you'll finish your Seesaw assignment. So the two numbers that we're going to compare are 0.60 and 0.6. And the first thing I notice is that we go out to the hundredths column over here. So I'm going to break out my area model into hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I've broken my area model up into hundredths, and I have 60 hundredths. I have 60 hundredths. Well, 60 is same as 10 times 6. So if I have 60 hundredths and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, well, it will be 10, 20, 30, 40, 50, and 60. So now I've filled in 60 hundredths, which is what this decimal represents. So now let's move over to 0.6. 0.6, I'm not going to worry about hundredths because it's only broken up into tenths. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And again, I know that my area model isn't perfect, but really we're comparing the amount. So if they're not exactly the same size, that's okay. And then I notice that I have to color in 6 of those tenths. 6 of those tenths. So I'm going to color in 1, 2, 3, 4, 5, and 6. So now I have 60 hundredths colored in over here and 6 tenths colored in over here. And I actually did something that made this problem a little harder than it had to be, and that's that I colored them going in different directions. For this one, I colored going across, and for this one, I colored up and down. And that actually is going to make it a little bit harder for us to see. So in an ideal world, if you're drawing it out, whatever way you decide to go, you want to pick going to both ways. But since I've already done this, that's okay, we'll move forward. If I look at it, I can see that over here, even though I've colored in the hundredths, what I really have is 6 tenths colored in, right? A whole tenth, a whole tenth, a whole tenth, 4, 5, and 6. 6 tenths colored in, even though I broke it up into hundredths. Over here, I have the same thing. I didn't break it up into hundredths, but still 1, 2, 3, 4, 5, 6 tenths. So I can see that I have 6 tenths colored in on both of them, 4 tenths remaining on both of them. So I know that these two numbers are equal. Now you're going to go finish your independent work, whether that's Seesaw or your Google form. And remember, as always, to have a great day. Goodbye.